Good morning, everyone. This is Miss Hala, and today we are going to have a new lesson, which is a geometry lesson, and our session today is about similarity. So let's start. Similarity. We have studied before the similarity, and today I'm going to review some information with you, and also we are going to take new Carly and theorem concerning this subject. Now, similarity of two polygons. Two polygons are similar if the following two conditions are verified together. First, their corresponding angles are equal in measure, and second, their corresponding sides are equal in proportion. Now, let's have the first condition, which is the measure of the corresponding angle. If I set the shape A, B, C, D, and I have another shape which is X, Y, Z, L, and I told you that the measure of angle A equal the measure of angle X, also measure angle B equal measure angle D, and Y and D equal L, and also C equal Z. And also I told you that there is a proportion or a fixed ratio between its side length. Like if we said that AB over XY equal BC over YZ equal CD over ZL equal DA over LX. And these ratio also have the same ratio of the perimeter. So the perimeter of the first shape is proportional to the perimeter of the second shape. And all these ratios is equal and have a constant value. In this case, we can say that the two shapes are similar. So A, B, C, D is similar to X, Y, Z, L. Now let's move to another point. Here we have some important remarks. In these remarks, it is said that if the ratio between two similar polygons is greater than 1, this is an enlargement. And if it is less than 1, so it is minimizing of the polygon. And if the ratio is equal to 1, therefore it is congruent polygon and not only similar polygon. Now here is another important remark. The two conditions, which is the equality of the measure of the angles and the proportion of the lenses of the side, it has to be verified both together in order to say that the two shapes are similar. Otherwise, if you have only one condition, so this is not a similarity case. Also here we said that congruent polygons are similar, but not all similar polygons are congruent. And if each of the two polygons are similar to a third polygon, two polygons are similar to a third one, then these two polygons are similar to each other. And finally, the corresponding vertices should be kept in mind in order to facilitate your handling of the problem or solving the problem. These are some important remarks you should put in the consideration. Now, let's go to similarity of triangle. Actually, triangle is considered a special case. Why? Because in triangle we shouldn't verify both conditions. We need only to verify one of these conditions. Either the measure of the angle are equal or the sides are proportional. But we said before, in order to verify similarity, we have to verify the two conditions. Yes, and we said also that triangle is a special case. So in triangle, two triangles are similar if one of the two conditions is satisfied or verified. Now, let's go to the AA postulate. Actually, this leads us to this postulate. Because we said that we can use only one of these conditions to verify that the two triangles are similar. So what if I have two triangles and I have two angles equal in measure to another two angles in another triangle? So this is 110 and this is 110. This is 30 and this is 30. I have here two angles only. And we said that you have to have all the angles equal. Yeah, I know. But what about that the measure of the third one equal the measure of the third one? Why? Because all of us know that the sum of angles, the sum of the measure of the angles of a triangle is 180. So I can calculate this angle by using the rule 180 minus 110 and 30. So this is going to be 40. And here it is the same. This is going to be 40. So the measure of the three angles are equal to the measure of the three angles. So if I have only an angle and another angle equals, so two triangles are similar to be if two angles of one of them equals the measure of the two angles in the other triangle. Now let's check the corollary number 1. Here it is said that if a line is drawn perpendicular to one side of the triangle and intersect, this is perpendicular to one side, and it intersects the other two sides, or the line containing them, then the resulting triangle is similar to the original one. Let me explain this by more details. Now I have here a triangle and I draw a parallel line to one of these sides. This parallel line intersects the other two sides at 2 points and create a new triangle. This new triangle is said to be similar to the original one. So ABC is similar to AC, similar to AEF. Why? Let me explain this. Now here we have two parallel lines. What about the corresponding angles of the parallel lines? Measure of angle E equal measure of angle C, as they are corresponding angles. So in this triangle I have an angle equal in measure with the big one. Now let's go to this one. Measure angle F or AFE equal measure angle C, and they are corresponding angle. What about angle A? It is a common angle in the two triangles. Therefore, these two triangles are similar. Okay, now try to prove this case. Here we have a triangle and this line is extended, this one is extended, and here is a parallel line to the third. Now, these two triangles are similar. Why? Because these are two right angles, therefore measure angle A equal measure angle D, alternate angle, and measure angle B equals C, also alternate angle, and measure angle AMB equal measure angle CMD, vertically opposite angle. Now in this case, I want you to try to prove that the original triangle, which is ABC, is congruent to the small one here, which is CBD. Now let's move to another point. Here is an example, and he said in this example, if AB parallel to ED, find N and L. Now let's try to prove or find the value of M and L. Now he said that these two triangles are similar. And no, he didn't say. He only gave me that AB is parallel to ED. AB is parallel to, I'm sorry, this is BC. BC is parallel to DE. Now let's go and try to prove that these two triangles are similar, and therefore we can find the value of L and M. Now we have two parallel lines, therefore the first triangle, which is ABC, is similar to the second triangle AED, as we said before. So triangle AED is similar to triangle ACB. Now these two triangles are similar. So we are going to find the ratio. The first ratio is AE over AC equal to ED over CD equal to AD over AB. AD over AB. Now, let's start with AD. AE. EA equal L minus 1 over AC, which is L minus 1 plus 3. Here we have L minus 1 plus 3. This ratio equal ED, which is 2 centimeters over 6, which is CB. Now we're going to simplify. So this is L minus 1 multiply 6 equals 6, L minus 6 equal, this is 2L, and this is negative 1 plus 3 equals 2 times 2 equals 4. Now let's have the L in one side and the numbers in the other side. So I move 2L to this side and 6 to this side. Therefore 4L equal 10, and from this L is 10 over 4. And by using the same rule, you can find the value of M. And the end of our session. If you need any question, please let me know. Keep in touch and try to study hard, because this is a very easy lesson and you can do it. Thank you.